Imagine for a moment that our Sun wasn't 1.4 million kilometers across, but just 1 meter, a sphere the size of a yoga ball, glowing with the weight of a real star. Now, what happens to everything else? The planets, the distances, and our place in the galaxy. Today, we are shrinking the entire solar system.
SYNRIX.
Let's start with a simple but incredibly powerful thought experiment. Imagine the Sun not as a massive sphere of nuclear fire, but as something you can actually stand next to. Shrink it down all the way until it becomes a perfect, smooth, glowing sphere just 1 meter across. Now this might look small enough to hold, but the scale behind it is absolutely gigantic. Because when the Sun becomes 1 meter wide, every planet in our solar system collapses into something so tiny, so delicate that you could lose them between your fingers. We begin with Mercury. At full size, it spans nearly 5,000 kilometers. But when forced through our shrinking ratio, Mercury collapses into a perfect 3.5 millimeter bead, not even the size of a dried lentil. In this miniature solar system, Mercury becomes something you could accidentally inhale. Venus, Earth's evil twin, survives the shrinking with a little more dignity. A world of runaway greenhouse heat and crushing atmosphere pressure becomes a sphere just 8.7 millimeters wide, a yellow marble, smooth and deceptive. And now, Earth, the only world we know that carries ocean, continents, forest, and life. When reduced to the same scale, our entire planet shrinks to 9.1 millimeters, a tiny blue glass bead. If you held this scaled Earth between your thumb and index finger, every human civilization that has ever existed would fit comfortably underneath your fingernail. Mars becomes a 4.9 millimeter red pellet, a frozen amber drifting far beyond Earth's orbit. Then comes Jupiter, a world so huge it dominates the entire solar system. And in our miniature universe, Jupiter becomes a 10 centimeter sphere. But even this single tiny ball contains more mass than the rest of the planets combined. Saturn shrinks into an 8.4 centimeter sphere, but its rings remain the most delicate structure in the solar system. Once stretching hundreds of thousands of kilometers, the rings now span just 20 centimeters, thinner than the edge of a razor blade. The ice giants, Uranus and Neptune, become two cold marbles, each around 3.5 centimeters, smooth and silent. Now that we have shrunk every planet down to a handful of millimeters, it's time to look at the distances between them. Because in real life, the solar system is mostly nothing. A gigantic desert of vacuum where worlds are scattered like dust around tens of billions of kilometers. So let's scale the distances properly using our 1 meter Sun. Start with Mercury, the closest planet to the Sun. On our scale, this tiny 3.5 millimeter world orbits at a distance of 41 meters. Venus, the pale yellow marble, drifts 77 meters away. Earth, our blue 9 millimeter home, sits 107 meters from the Sun. Meaning, if the Sun was glowing in the center of a soccer field, Earth wouldn't even be in the stadium. It would be outside the fence. And this distance is so precise that even a slight change can erase any chance for life to ever begin, let alone evolve. Mars, the red lentil, floats at 163 meters. By the time you reach Mars in this model, the sun behind you is already fading into bright dots. But the real shock comes when we step beyond Mars. Jupiter doesn't appear until you walk 560 meters away. Saturn sits 1.03 kilometers from the Sun. Uranus waits at 2.06 kilometers. Neptune at 3.23 kilometers, which means from one end of our shrunken solar system to the other, you would walk more than 6.4 kilometers. A model solar system stretched across an entire city. Even after compressing the solar system into just a few kilometers, the emptiness is still overwhelming. And now, where is the next star? On this scale, Proxima Centauri, the closest star to us, is not 10 kilometers away. It sits an unbelievably 26,000 kilometers from our 1-meter sun. Imagine placing our 1-meter sun somewhere on Earth, any country you like. From that point, you would have to travel the entire 12,700 kilometer diameter of Earth, and then you would need to travel entire Earth diameter again. Only after crossing the equivalent of 2 full planets would you finally reach Proxima Centauri at this scale. So now, stretch that scale to the galaxy. On the same scale, the Milky Way's diameter becomes 682 billion kilometers, a disk so large that even in our ridiculously tiny universe, it can't fit on a planet, not even close. And inside this impossible structure, in that 680 million kilometer space, live hundreds of billions of suns, each one in our model, another glowing world. Each one in our model, another glowing 1-meter sphere, drifting alone through a desert of darkness. So now we understand scale. We have seen how stars drift alone, separated by distances so huge that even in our tiny universe, they feel untouchable. And after all this, something becomes very clear. We are unbelievably small. Our solar system is a speck, Earth is a grain of dust, and we, everything we have ever been, are almost nothing. But here's the twist. Being small doesn't mean being rare, because once you zoom out far enough, you start seeing patterns. You start realizing that our sun isn't special, our planet isn't unique, and Earth, this perfect world for life, might not be a one-time accident. Earth-like planets are common, very common. Statistically, our galaxy may contain 300 million Earth-like worlds, planets roughly our size, orbiting their stars in the habitable zone, where liquid water can exist, and the closest one may be just 20 to 40 light-years away. Numbers this large mean nothing until you make them physical. So let's do that. Imagine every Earth-like planet as a small sphere just 10 centimeters wide. Now take all 300 million of them and stack them together. Not across continents, not across oceans, just upward. What you get is a structure with the volume of a giant skyscraper, something on the scale of the tallest buildings humans have ever built. 300 million worlds reduced to a shape you could point at, and that's just one galaxy. This is what the universe looks like when numbers turn into reality. Not crowded, not alive with motion, but vast, cold, patient. Somewhere inside this scale, inside this enormous nothing, a world 9 millimeters wide keeps orbiting, quietly, precisely, and unnoticed. We are not at the center of anything. We are not large. We are not special in size. But we are here, looking outward, compressing the universe just enough to understand how small we are.